Hey guys, so today I'm going to be working a little on reading the sectors so we can start continuing on with the bootloader because since our OS isn't going to be fitting on 512 bytes, which is our boot sector, it needs to read another sector to continue on with the boot processor. It's gonna start handing it to the OS. So yeah. So right now I'm just going through this document that shows a little bit of the registries for disk functions and just going through the sector numbers and the tracks and the cylinders. So yeah, if you don't understand kind of like how a hard drive is built, it's we have let's see, I don't know if I have like something to draw. I don't know what this is, but okay, so yeah, so a hard drive usually, what the fuck? So we have these plates here. Why is it doing that? We have these plates. These plates here, okay, I'm a really bad drawer, but they're usually more compact than this. So let's say we have three plates. We have tracks, which are these ridges on top of the cylinders. I'm doing a really bad drawing. I'm gonna show you like an actual example of how they look in a second. So yeah, here we have the tracks, and then there's usually like some type of assembly arm that will read and write from everything. Then we have like freaking like a stick almost in between all of these. So sorry. Yeah, so we have two tracks, we have plates, we have the assembly arm, and the cylinders are what makes up these. If you put a imaginary dotted line between these tracks, like looking sideways, and there's dotted lines coming down, these are what makes up the cylinders. So there's two cylinders. In this instance, it'd be two cylinders. One connecting all the track ones, and then another one for track two. So it'd be like, let's see if I can. Um, I don't know. This is like a really bad like. I'm not gonna do a dotted line, but nice. This is amazing. So there's one would be right here, and then another one would be right here, and then another one would be right in the middle. So those are our cylinders. So there is and then sorry, I'm just trying to remember I just like lost my train of thought. Yeah, and then we have our sectors. So a sector is just like a chunk of these two tracks. It'll be like this. Then there's a lot of sectors, and I think hard drive don't necessarily have only two tracks. I think there could be more than two. I think in just a lot of examples, there's like two or three tracks to keep it simple. But yeah, so a sector is like one chunk of a plate, or I don't know if it goes through all three of them, but it might just be one. I'm not too sure about that. But yeah, so sector is just like a chunk of it. And so there's like something there's like more specific in terms of like access time, seek time, read time, transmission time. Um, but yeah, I think I have a note here specifically on that. Oh wait, I have a note. So yeah, okay. So the seek time would be the time it takes to move in between tracks or cylinders. So that's one. Then we have our rotational latency, which is the time for this assembly arm to move to a specific sector. So this will rotate, which is why it's called rotational latency. The hard drive will, like the plates will rotate, and then that's where the arm will essentially go to a specific sector. And then we have our okay, yes, this would be our seek time and rotational latency. Then we have our access time, which is basically the rotational latency and the seek time added together. So it's the time it takes to get to a sector, then it's the time it takes to get, or time it takes to pick the track and then go to the sector. And then we have our read time, which is the time required by the read-write assembly arm to read the whole entire sector. That's called the read time. So once it's actually there, it reads the whole sector. And then finally, transmission time is the access time plus the read time. So yeah, and essentially, like, this is just how a hard drive works. And it's going to be kind of essential for us to understand, I think, this for when we start reading other sectors besides our boot sector. Okay, so let's see. So in here, it's telling us, okay, this is the read sector function. This is where we have to start at. So then we wouldn't use 0, since 0 is for a floppy. We're going to be using, I think, a hard drive, so it'd be 2. Yeah, no, it'd be 80H. And then but the thing is that I don't understand is there a reason why we're going to the third cylinder? This is what I'm not kind of understanding. And why are we going specifically to the fourth sector? Okay, let's So they're making the disk load on a subroutine. So I think we're gonna do something similar to that then. So this is what I had so far. So we're gonna make another file. Let's make more space on my desk. Disk load. Wow. Disk load. Okay. I don't know. Let's make this label. So then whenever we start, we can call this. Okay, let's keep going. Let's see. So what we're gonna do is take this code, run it here. Oh, so I did do some stuff off camera. I changed the color, so sorry. Oh. Did I save? So yeah, I changed the color to red, and then I was just messing around. This is not 80 by 25 mode. This is 40 by something. There's, if you guys want some documents on this, it's it's not here. It's this one right here. So it tells you, so one is 40 by 25, and then 3H, which is what I had it before, or 03, is 80 by 25. So you can make it bigger, you can make it smaller. This, for me, it's technically supposed to change the size of your window, but it's not. It changes the like how much text I guess you can have in a window, but it's just changes the pixel resolution as well, and the text resolution. So you could probably play around with that and see what you could do. There's a lot. And then for the color, I just went to here. So there's color attributes, and then this is binary, and you just convert it to hex, and then or you convert the binary to decimal. Well, that's what I did. That's why. So red is 4. So red 1 2. There's in the two first places. Now this is 1 4 here. So yeah, and if I change it to, let's say, let's do 3, it's gonna be cyan. Yeah, so you can change it to color. You can change the color that way. So I think there's actually a max on the background. I think it's 7 or 8. So yeah, I could change it to green. So let's try and change it to green. Green would be 2. Yep, so that's how we change it. So I'll change it back to red for now. I'll just keep messing around with colors to see exactly what I want. But yeah, so that's how I did that. So let's continue. So this is the drive number, ADH being hard disk, hard drive. Because I'm not entirely sure, because there is, maybe this if you have another hard drive, I don't know, for 81H. And then 5 is, I think it's the sector. I don't know why my space is like just not working. And then this is our BIOS interrupt. So select the cylinder. So I guess now we're gonna select the cylinder. Start at 2. And then so we did the drive number of sectors to read, selecting cylinder number. I might have to move number of sectors to read a little further down. So now we did the cylinder, now we should select the track. Let's do 1. I don't know if that's gonna work. I think they should though. And then CL is the sector. And then, what was it again? CL. The reason is I don't know why they're doing 4. Since this is a base of 1. So AH, okay. Drive number. DH is saying the head number, but it's I guess the track. But then CH is saying it's okay, cylinder number. And then AL is the number of sectors to read. I don't know if that's how many. What the hell? I don't know if this is so yeah, right, number of sectors to read. And then CH is technically cylinder track number. DH is what I'm confused about. I guess it's the track. And then CL, sector number. actually plug this in the ChatGPT and explain this for me. Okay, head is track. Okay. So CH is the cylinder, and then DH is the track. The fourth sector on the track. So CL is a sector on the track. So yeah, so then what does AL do then? That's what I'm wondering. Read a total of 5 sectors. Oh, so this is the starting point from before? Oh my god, we are reading, I guess. My keyboard is actually ass. So move AL means we are reading 5 sectors past the starting point, which is 4. Okay, so that makes sense. So these should kind of be moved. Because we want to select our starting point first and then read. What is ES again? Like our offset addresses or segment registers, yeah, okay. That's where it does the times 16, whatever the hell. It does like that calculation where it'll do multiply by 16 and then it will adjust by the label address, which will give us like our offset. So, okay, that kind of makes sense. I mean, I don't think we don't need to do. But why are we picking this address? I guess we'll go with this yeah, so this basically, so what it'll do is this destination address will be multiplied by 16 once it's moved into BX. Yeah, then it's indirectly sets ES to 0xa000, but then it's added by this because once you put this address into BX, which BX already indirectly has 0xAAA. Okay, yeah, that makes sense. I think that's yeah. Okay, so I was right. So we can do BX 0x800, and then removing BX into that, and then move BX 0, 1, 2, 3, 4. Note, for one reason or another, we indexed a sector beyond the limit of the disk. An attempt was made to read a faulty sector. The floppy disk was not inserted into the drive. BIOS may fail to read this first. It's important to know how to detect this. Otherwise, we may think we have read some data, but in fact, the target address simply contains some random bytes it did before we issued the read command. Fortunately for us, BIOS updates some registers to let us know what happened. The carry flag or the special flags register is set to signal general fault, and A will set the number of sectors actually read. We opposed to the number requested. After issuing the interrupt for the BIOS, we can perform a simple check as follows. I forgot to put an interrupt. are reading the sectors too. Measure 0x directly stored in BS. Calculation 0x44 times 16 plus 54. Give us the offset. And there's a check here. Just check is another jumping instruction that jumps only if the carry flag was set. One second. Like, the thing is that I don't like about this shit is that, yeah, they'll go through here and then look, they'll just add a bunch of random shit, like, not random shit, but shit that they just didn't even explain. Yes, this is basically how it is. Okay, let's see. It's printing hex, okay, but I don't. I'm gonna take these two and put them at the bottom here. let's check this code actually. There's this guy that kind of makes it a little more clear that I like to watch, so I think I'm gonna do his. Damn, so my microphone hasn't even been recording. Holy shit, wow. Was my headset not even on? I'm confused.